Hello, in this video we will see the 5 transistor OTA and few of the concept that what is the meaning of active current mirror, what is the meaning of that. Second is we will visualize the large signal analysis and also we will visualize the small signal analysis. So in this video we will be going very crisp way of analyzing the 5 transistor OTA. So this is the 5 transistor OTA where transistor 1, 2, 3 and 4. So at the input, if you see, this is the common mode voltage, input common mode, and the difference between V1 and V2 is equal to V1 minus V2 is equal to delta V in by 2 minus okay. So we have difference between V1 and V2 is delta V in. So this is the way of analyzing the circuit in term of input voltage. Now this, if you see, is the current mirror, and we will take the output from this node in open load. Basically the output is with respect to ground and open at this node, and this is the bias source resistance, source current. Okay, so let's see what is the meaning of active first. Before that also I want you to visualize that this 5 transistor OTA is called as operational transconductance amplifier. So why transconductance? Because input is Gm and here we have I, so delta I by delta V. So current and voltage, basically the MOSFET conversion is from voltage to current, so that is why it is called transconductance, and this OTA means operational transconductance amplifier. Second thing I want you to visualize that V out is single ended and input is differential ended. What does it mean? That V1 minus V2, and this is equal to delta V in. So we have delta V out by delta V in as voltage gain. Okay, so this is double ended to single ended conversion. Also, if you see here, this is a differential pair with current mirror as a load, and this current mirror is called active current mirror. So now let's see what is active current mirror means. Okay, so here if you see that if we increase the input voltage, the current in this branch will increase, and since it is a current mirror, the current here also increase, and thus this I1 is being used here as I2. Okay, basically the current from the M4. Okay, so I1 is being used here at M4, so that is why this structure is called active current mirror. Okay, now second thing is, if you see, we in the active current mirror, we will use the input signal current. Because of input signal change, current changes in one branch, and that current will be used here at the output side also. So that is the basic meaning, that the input signal is also being used at the output side. Okay, now let's go to the second point, that we will see the large signal visualization of this this circuit. Okay, so so let's begin. Here if you increase the signal, and we are talking in term of large signal, not the small signal. Okay, so if you increase this, what will happen? Current will increase here. Okay, and since current increases, this voltage will decrease. Why? Because this is diode connected PMOS, so VGS will increase. For this current increase, VGS will increase, and this voltage has to go down. Okay, because this is diode connected, so current to voltage conversion basically. So here the voltage will decrease. Okay, and because of this voltage decrease, current from M4 will increase. Okay, because if this voltage, if this M4 is in saturation, this current will increase. Okay, now that is the first point. Second point is, if this side input voltage is decreases, the current through this branch will decrease. Okay, so from the top if you see, this side current increases, and below the current will decrease. So what does it mean? It means that this voltage will increase. Okay, so why it is increasing? Because let's say this is a cap here, and current from these two, this current increases, so this will, the V1 increases because of I1, let's say I4. Because of I4, current will increase, voltage will increase here, and this current also decreases. Decreases means whatever the current flowing before input change, after that this current has decreased, so this will increase more. Okay, so we can say that this potential, this at the V out, the output voltage will increase. Okay, and important point is that the left hand side input current is being used here at M4, from M4 to the output. Okay, so this is the way of visualization in term of large signal analysis. And important point is, let's say when V input at right side will become 0, then the current through M2, i M2 is equal to 0. This current will be 0. So if you know basic concept of MOSFET, that whatever the VG voltage, if VGS is here high, mod of VGS is very greater than VTH, but because of no current here, open circuit, I is equal to 0. So what does it mean? This means that, let's say I have plotted for nmos. So because of that, VGS is greater than, let's say I plotted for just graph is just nmos, concept is important. So VGS is greater than VT, but current is 0. So it means VDS will be 0. So this VDS difference is 0. So this voltage will become VDD. Okay. And only important thing that here we should know from our analysis is that this current from M4 increases, and current from M2 decreases. So basically this current increases and this current M2 decreases. Because of that, this potential will increase. So this is the basic concept here. Okay. Now let's go to the third point, that is small signal visualization. Okay, small signal visualization of this circuit. So small signal is very simple. Let's see here what it is. That So above was diode connected, so I replaced with the 1 by gm3. Okay, this is plus v in by 2, this is minus delta v in by 2. Okay, and let's increase this voltage. It means that this current will increase by delta, let's say. So what does it mean? It means that this potential will decrease. How? Because this is 0 volt, and if one node is 0 volt and you are increasing the current from the branch, it means this voltage VA is decreasing in negative direction. Means let's say it is 0 R and earlier it was, let's say for example, minus 1. Okay, now if you increase the current, so what will happen? This voltage will decrease. Okay, so in magnitude you can say it is increased, but direction is negative, that is why I am saying it is decreasing. So in term of magnitude it has increased, but direction is negative, so that is why I am saying it is decreased more. Okay, now let's go to the other side. What will happen? This voltage is decreased, so let's say I2 is decreased by delta. Okay, now from here let's say VA. What is VA? VA is nothing but some delta. Okay, so we want to know here that I1 is increased by delta, and because of that VA has some delta, and we will propagate this delta in I1 to I4, because whatever the change in VA will be gone to M4 V, M4 VA VG gate of M4. So let's say I1 is increased by delta, then VA the voltage across this diode connected will change, and that change will be same at the M4 VG. So because of that, the I4, the current through this MOS increased by delta. Okay, so if you see here clearly, this is increased by delta plus delta, and this is decreased by delta minus delta current. We know that we have R0 at the M4 also, so this is R0. So here current is increased by delta, here current is decreased by delta. What is the current here? In this direction the current will be increased by 2 times of delta. Hope you are able to visualize what I wanted to depict. I wanted to explain you here that current is increased by 2 times of delta, and because of that, what is the VB here? VB will increase. Okay, VB will increase. So we are not calculating the exact value of the VB, we are just visualizing that what will happen if this voltage is increased and this voltage will decrease, then what will happen. So in this way we can see that in the small signal, if this voltage is increased and this voltage is decreased, this potential VB will increase. Similarly, in large signal we saw that this voltage is increased and this voltage is decreased, gate voltage, this V out has increased. So in large signal also, in small signal, the value is increased when this side is increased in both the cases. And the analysis, how we will do the analysis in small signal and large signal is quite different. Okay, so this is the basic thing about the 5 transistor OTA. So hope I am able to explain you in terms of visualizing the circuit in large signal and small signal. So we will see more detail in another video.